to week 9 for junior cycle ordinary level. So today we're going to be looking at interest and introduction to patterns. So it's going to be split into two sections. So we'll look at interest first. So I'm going to go through a very important formula that you will get in your log tables, and then we're going to look at some exam questions. So the formula that you're going to need is F is equal to P bracket 1 plus I to the power of T. And this formula you will get in your log tables. Now, you need to know what each of these things mean. So F stands for final amount. P stands for principal. I stands for interest rate. And then T stands for time, and the time is going to be in years. So we're going to do an example now, and we're going to apply this formula to the example. So suppose €100 is invested in a savings account. For 5 years at an interest rate which is known as AER. So AER is annual equivalent rate, so it's interest of 5%. And then what you're asked to do is calculate how much money is in the account after 5 years. Okay, so what we need to do here is figure out, now I meant to say actually the principal, that's your starting amount. So I'm just going to put that up here. So that's your starting amount, the amount of money that you start off with. So you're told there that €100 is invested in a savings account. So that's going to be your principal. So €100 is your principal. Now you're told that it's for 5 years. So that's going to be your time, which is T. And you're told the interest rate is 5%. Now we need to convert that to a decimal, so it's going to be 0.05. So all you have to do is put it into the formula now. So F is equal to P bracket 1 plus I to the power of T. So F is your final amount, which is what you're looking for. So F is equal to the principal, which is €100, multiplied by 1 plus the interest rate, which is 0.05, to the power of T, so the time is 5 years, so that's the power of 5. And you can literally put that straight into the calculator, and when you do that, you will get an answer of €127.63. So the answer is, after 5 years, there's €127.63 in the account. So the main things here are, you need to know what each of these things mean. So F is your final amount, P is the principal, which is the amount you start off with. That's just 1. I is the interest, and you need to convert that to a decimal. T is the time, and that's in years. So you're just literally putting it into the formula. Okay, so I pulled this question from 2015, and it's the sample paper. It's paper 1. So Dermot has €5,000 and he would like to invest it for 2 years. A special savings account is offering an annual interest rate of 4% if the money remains in the account for the 2 years. Calculate the interest that he would earn for 1 year. Okay, so, or for year 1. Using the formula, F is equal to P by 1 plus I to the power of T. So our final amount is what we're looking for. Our principal is the starting amount, which is 5,000. Our interest is 4%, which is 0.04. And then our time is in years, and that's 2. Now, actually, in this case, we're asked to find out how much he earns after 1 year. So I'm actually going to change that to 1. So our time is 1 year. Okay, so we're literally just plugging it into the formula. So F is equal to, so the principal is 5,000 by 1 plus, so interest is 0.04 to the power of t, which is 1. So you literally just plug that into the calculator and you get 5,200 euro. Now, you were asked to calculate the interest that he would earn for year 1. So the interest he made is going to be the final amount minus the principal. So it's going to be, so let's do it over here actually. So 5,200 minus 5,000, and that's 200 euro interest for part 1. So if we look at part 2, tax of 27% will be deducted each year from the interest earned. Calculate the tax on the interest from part A. So let's write down what the interest was from part A. So the interest from part A was 200 euro, and you're taxed 27% on that 200 euro. So we need to get 27% of 200. So 200 by 0.27. You put that into the calculator, you'll get 54 euro. So the tax on the interest from part A is 54 euro. Part 3, find the amount of the investment at the start of year 2. Now, they've given you a calculation there, so it's going to be 5,000 plus the interest, which was 200, minus the tax, which is 54. And again, you literally put that into the calculator. So it's 5,000 plus 200 is 5,200 minus 54 will give you 5,146 euro. So that's part C. And then for part D, find the total amount of Dermot's investment at the end of year 2 after the tax is deducted from the interest, and give your answer correct to the nearest euro. So for part D, we need this formula again. F is equal to P by 1 plus I to the power of T. Now this time, so we're looking for our final amount. Our principal for the start of year 2 is the end figure for end of year 1. So our principal is going to be 5,146 euro. Our interest stays the same, it's 0.04. And our time, again, is 1 year because we're going year by year. So we need to get the final amount at the end of year 2, and then we'll get the tax of the interest. So the final amount is going to be the principal, which is 5,146 by 1 plus 0.04 to the power of 1. So you can put into the calculator 5,146 by 1.04, and you'll get your final amount of 5,351.84. Now that's your final amount. You want to find out how much interest you made between year 1 and year 2. So that's going to be the final amount here minus the final amount at the end of year 1. So it's going to be 5,351.84 take away 5,146. So you put that into the calculator and you get 205 euro and 84 cents. So that's how much interest he made on the second year. Now don't forget that that interest is taxed at 27%. So you need to get 27% of the interest. So it's going to be 205.84 by 0.27 to get the interest on that tax. So it's 205.84 multiplied by 0.27. And you get 55 euro and 58 cents. Now I'm just going to finish it up here. So remember the formula we had from before. So find the amount of the investment at the end of year 2 or the start of year 3. So that's going to be your starting figure, which was 5,146, plus the interest, which was 205.84, minus the tax, which was 55.58. When you put that into the calculator, so it's 5146 plus 205.84 minus €55.58, and you will get €5,296 and 26 cents. So that's the total amount of Dermot's investment at the end of year 2 after tax is deducted. So 5,296.26. Now it also says they're correct to the nearest euro, so let's round that. So 5,296 is going to stay at 5,296 if we round it. So that's the answer, the final answer there. Okay, so I have another question here, and this is from the 2015 paper 1. And it's to do with discounts, costs and discounts. So Daniel wants to buy a bike. The usual price of the bike is €320. The bike is on special offer in 3 different shops. Shop A offers 10% off the usual price of the bike. Fill in the table below to show the special offer of the price of the bike in this shop. So we need to get 10% of €320 and take it away to get the special offer price. So the way we get 10% of €320 is we multiply 320 by 0.1. Now when you put that into the calculator, you get €32. So there's a €32 discount. So the way we get the special offer price is the total price, which is €320, minus the discount, which is 32. And when you take that one away from the other, you get €288. So that's the special price, so that's the figure that goes in here. Shop B offers a quarter off the usual price of the bike. Fill in the table to show the special offer price of the bike in this shop. So a quarter is 25% or 0.25. So we need to get 25% of 320. So if we multiply 320 by 0.25, you get €80. So this means that Daniel is getting €80 off. So it's going to be €320 minus 80. When you put that into the calculator, you get €240. So that's the special offer price here, €240. And then finally, in shop C, Daniel can pay €60 now, plus €20 at the end of each month for 12 months. Fill in the table below to show the special offer price of the bike in this shop. Okay, well, he's going to pay €60 now, so that's €60 plus €20 at the end of each month. So we've got 12 months in total, so it's going to be €20 by 12. So we need to get that figure, so that's going to be €60 plus 20 by 12, which is €240. And when you add both of those together, it's €300. So the special offer price there is 300. Now for part D, it says, do you think Daniel should buy the bike in shop A, B or C? So we look to see which of the options is the cheapest. So offer A is 288, offer B is 240 and offer C is 300. So the cheapest there is offer B. So the reason is that it's the cheapest at €240. That's straightforward enough. Okay, so we're going on to the second section now, which is Introduction to Patterns. So there's a couple of things that I'm going to go through before we go to some questions. So the first thing is a pattern that is given as an ordered list is called a sequence. Second thing is a pattern of numbers is called a number sequence. And the last thing is we're going to look at as a linear pattern. So a linear pattern or sequence means that the difference or change between one term and the next is always the same number. And I'm going to show you an example of that now in a minute. Okay, so I'm going to go through a couple of examples of that. So if we were given the sequence 3, 7, 11 and 15. So I'm going to label these. I'm going to call this term 1, so T1. I'm going to call this term 2. I'm going to call this term 3. And I'm going to call this term 4. So you've got 4 terms there. Now if we were to look at the difference between the terms, so the difference between 3 and 7 is adding 4. The difference between 7 and 11, you're adding 4. The difference between 11 and 15, again, you're adding 4. So this is a linear sequence because the difference between the numbers is the same, okay? So this is a linear sequence. So the difference between the terms is the same or constant. Okay, so we call that the first difference. So I'm just going to label that the first difference. There's 2 other types of sequences or patterns. So we have quadratic and we have exponential, and I'm going to explain what they are on the next slide. Okay, so we're still in the second section, so introduction to patterns. So we have another type of pattern and it's known as a quadratic pattern. And the way we can find out whether it's a quadratic or not is we actually get what we call the second difference. Now the way we do that, so I'm going to give an example here. So if we had the example 7, 8, 12 and 19. So we're going to do the same thing here. So we're going to call this term 1, so T1, T2, T3 and T4. The difference between 7 and 8, we added 1. The difference between 8 and 12, we added 4. The difference between 12 and 19, we added 7. Now that's called the first difference. And we can say that that's not linear because the first difference isn't the same. If it was linear, all of these would be the same number. So now what we're going to do is we're going to actually go and get the second difference, which means we're going to get the difference between these numbers. So to get from 1 to 4, we added 3. To get from 4 to 7, we added 3. So you'll start to notice now that the second difference is the same. So I'm going to label that the second difference. When the second difference is the same, it's known as a quadratic. Okay, so I'm going to just put this up here. So when the second difference is constant or the same, the sequence is quadratic. And then the third type is called an exponential. And again, I'm going to use an example here. So I'm going to use 10, 20, 40, 80. Now exponential means it's going to be either doubling or tripling. So we're going to do the same thing here again. We're going to call this T1, T2, T3, T4. The difference between T1 and T2 is 10, so you added 10. To get from 20 to 40, we added 20. To get from 40 to 80, we added 40. So we're going to check the second difference just to make sure that it's not a quadratic. The difference between 10 and 20 is 10. The difference between 20 and 40 is 20. So you'll notice that the second difference is not the same, which means it's not a quadratic. And the first difference is not the same either, so that's not going to be a linear, sorry. So the first difference is not the same, so it's not linear either. So it must be the third option, which is exponential. So that's when the pattern either doubles or triples. So let's just check that. If we double 10, we get 20. If we double 20, we get 40. If we double 40, we get 80. So it's an exponential pattern. So I'm just going to write that in. So a sequence that involves doubling or tripling is called an exponential pattern. So that's it, notes-wise in relation to patterns. So we're going to do a couple of questions now. Okay, so I pulled an exam question from linear patterns and sequences. So, so we're looking at the first question here. Fill in the first difference and the second difference for the following patterns. Some of pattern 1 have been completed for you. So, pattern 1 is 2, 4, 9, 17 and 28. So, the difference between 2 and 4 is 2. The difference between 4 and 9 is 5. That's been done. The difference between 9 and 17 is 8. The difference between 17 and 28 is 11. So that's the first difference, okay? Now, we will notice at this point that the difference isn't the same, so it can't be linear. So I'm just going to write along the side here to help us remember. So a linear sequence, so in a linear sequence, the first difference is the same or constant. Okay, let's look at the second difference now. So what's the difference between 2 and 5? How do you get from 2 to 5? So you're adding 3. How do you get from 5 to 8? You add 3. And the third one is done there. How do you get from 8 to 11? You add 3. So you will notice that the second difference is the same, which means that that must be a quadratic. So I'm going to write out here, in a quadratic sequence, the second difference is the same or constant. So that's just to help us remember. Okay, let's look at pattern 2. So the first difference, how do we get from -1 to 2? Think of your number line. How do you get from -1 to 2? You add 3. How do you get from 2 to 5? You add 3. How do you get from 5 to 8? You add 3. How do you get from 8 to 11? You also add 3. So you'll know, looking at this, the first difference is the same, so we're going to know that that's a linear sequence. The second difference here, the difference between 3 and 3 is 0. Again, the difference between 3 and 3 is 0. And finally, the difference between 3 and 3 is 0. So we know that the second pattern there is going to be a quadratic. And this brings us to the last part of the question. State whether each pattern is linear or quadratic and give a reason for each answer. So for the first pattern, pattern 1, we observed that the first difference was not the same. So if it's not the same, it can't be linear. Then we observed that the second difference, it was the same. So if the second difference is the same, it must be quadratic. So for pattern 1, it is quadratic. And we need to give a reason for that. So the reason is, in pattern 1, the second difference is constant. i.e. quadratic. So that's that answered. So it's really important that when you do answer a question, you back it up, especially if it is asked you for a reason. Okay, so for pattern 2, so let's look at pattern 2 again. The first difference was the same. The second difference, it's just nothing. So the first difference, there's all 3, which means that this must be linear. So the answer to the second one there, that pattern is linear. So the reason is, in pattern 2, the first difference is constant, i.e. linear. So they're pretty straightforward questions, and they're the kind of standard questions you get from the paper. So if you're able to do them, you should be able to do some more questions from exam papers. So I'm going to leave some links to extra video tutorials and other questions from both interest and introduction to patterns, and see if you can attempt them. I'd advise to go on to those links and have a look around, and I will speak to you next week.